In this video, I want to talk about nMap and scanning a network and using nMap in some of the basic formats and trying some of the traditional uses of nMap against some hosts and a particular network that I'm on. So first thing I'm going to do is log into my Kali operating system, and I'm going to check my IP address. So I'll do an ifconfig for my Ethernet interface, and I'm on the 192.168.92.128 network. So I'm just going to do a basic scan, and I'm going to poke around. I'm just going to see what's on basically the same network as myself. So we're going to start by basically doing a little overview of nMap, and then we're going to see what's on our network. So first thing I'm going to do is do an nMap TAC-H for help, and we're going to see what exactly specifically we have with just these help commands. Okay, so we're going to scroll to the top of our help file. We're going to scroll to the top to our help file, and we're going to see that the basic usage of it is basically nMap, then your scan types, any additional options that you want, and then specifically the targets and or networks. Now we're going to kind of do this in reverse because it's just easier to understand the targets first, then the options, then the scan types. So when it comes to the target, we basically can do specific host names, IP address, or whole networks. And they give you some examples of exactly what that looks like here. So if you want to use a fully qualified domain name, you certainly can do that. If you want to do like the subnet of a domain, you can do that as well by using CIDR notation /24, or you can do a specific host, or you can do a range of hosts by doing something like a 1-254. If you were given specific input or a specific host that you want to target, maybe you would have got this information from a vulnerability scan, or if you were doing a pen test, they would have said test these clients. You can actually create a list and then just import and reference that list. That way you don't have to type a bunch of IP addresses. So I highly recommend the lowercase I, uppercase L switch. And then you can do the IR, choose random targets. I specifically like this on doing a whole subnet because what it does is it randomizes your destination, and that's very, very helpful for trying to avoid detection in the event that you need to do that. When you just do a regular scan, it's rather noisy. And I want to illustrate this by using a graphical tool that I just love to death. They took it out of Kali a little while ago, but I just love it to death. It's Ether8. So let's go ahead and get that installed. apt-get install Ether8, ETHERAPE. And I'm going to just go ahead and install that. Select yes, and just go ahead and let that run and go through the install. And it'll take a couple seconds. Once it gets the files, it'll actually download them and install them. And it takes approximately like a minute or so for it to unpack. You know you're getting close to the end of the install when it hangs at basically at processing the triggers for the manual database or the application. Now that Etherape is installed, we can go ahead and launch the application just by typing Etherape from the command line. And it'll come up in a new window. And the reason why I like this, particularly for these types of illustrations, is we get to visually see how a tool like nMap goes out and starts auto-building a map of who's speaking to who based on the types of information you get to your network adapter card. If you don't do anything and don't send any commands, you're just going to get a bunch of broadcast traffic or things that realistically aren't of any interest. Like you'll see broadcast address, you see a multicast address here, so I probably got a multicast advertisement. Another thing that you can do while doing this lab is you can actually run Wireshark. Right, so I'll set up Wireshark as well. So this is good for you to actually capture the traffic. So I'm just going to type Wireshark from a new terminal, and we'll get that to load as well. So not only do I want to visually see the traffic, but I actually want to capture it as well. So don't show that again. That's just, hey, you're running this as root, and we're not going to run too much traffic, so that should be okay. capture, you can do a Control-I or go to the interfaces, and then select the interface that actually has the traffic being generated. In this case, we know that that's going to be the Ethernet 0 interface, and I could wait until I get a packet in here just to prove that there is traffic on these interfaces, but I'm pretty sure that there is, so we'll just go ahead and click Start. And if it wasn't, then we wouldn't get any results in the center of our Wireshark. So we'll just go ahead and let that run for a while. We can minimize that. Now let's go back over to our terminal and let's start doing some basic scans. All right, now that we understand basically the networking convention. Now this first specific scan that I want to talk about is basically the TCP full connect scan. So that's demonstrated by the nMap -scan lowercase s and a capital T, basically to our specific host or target. Now in this case, we don't know what's out there, so what we'll do is we'll just scan the whole network. So we'll do a 192.168.92. And you can put a host here or 0. So I'll just do 131/24, and then I'll basically go try to do a 3-way handshake with everybody that has 192.168.92 in common. I could further subnet that via CIDR notation if I want to, and I'll just go ahead and let that run. Now this is working. And the reason why I started Ether8 is because now we can actually go peek and see basically what this scan looks like and get a better idea of realistically what's going on behind the scenes. And you can kind of just get a feel for what's visually happening on the network. And if you see things speed up, well, you'll see it speed up. If you see a port scan all over the place, you'll see the port scan. If you see a large volume of traffic, you'll see things swelling bigger. Okay? Now, what I found here, okay, it found a couple hosts. I am in a virtual environment, so I'm not going to find too much. So it said starting nMap at a specific time. So I have a report, and I'd want to copy all of this for my documentation just for the records. But for here, I'll just leave it in the terminal. If I wanted to copy it, I would literally just right-click, copy. Okay, so I found a particular host, 192.168.92.1. Okay, which is typically a default gateway. I find ports 135, 139, 445, and 53, 57, and an unknown very, very high port, and it also says VMware there. So it's trying to guess that based on the vendor ID of the MAC address. Okay, then it found another host. Okay, in this case, we only found port 53, so I'm willing to bet right there that that's probably a DNS server. We found another host, 92.128. Okay, scanned 1,000 ports. All of them are closed, but the host is up, so that means it's basically responding to a ping. 92.131, and I find all sorts of stuff here. I find FTP and 25 mail, HTTP for a web server, Kerberos authentication 88, LDAP, so that means it's probably Active Directory, port 445, that's another indicative port of a Windows server, also 464, which is another Kerberos component, also secure LDAP, so 636, so it's a little encryption. IIS, okay? So as you can see, the list goes on, and there's a VNC. I'd probably be interested in that. And guess what? NetBus, that's also interesting, running in port 12345. All right, so that's all of interest. And then I would go through the remaining time, and then finally nMap will summarize and basically give you a complete wrap-up on how much time. But just for the record, if I were doing this and I wanted status, if I just hit enter here a bunch of times, and I'll cancel that because we don't need it to complete, it'll actually tell you where you are and what percentage it is in the process. And depending on the type of scan you do, some of them take a long time. You want to go get coffee, and then other times, you just wait, a couple seconds, and boom. But what I like specifically about the, hitting enter a bunch of times is this is how you actually learn in detail what was going on. So I can see I was basically doing an ARP, then a ping scan, all right? And I can check to see that that was done, and that was part of some of the traffic that went back and forth between the hosts. Other things that I can do is I can look at Wireshark at this point and also look at to see what types of traffic was through. So there's a whole bunch of TCP traffic. And again, I did do a TCP three-way handshake and a full complete TCP scan. So I would definitely want to see a bunch of TCP here. But let's see if anything else didn't happen. In the very, very beginning, I can see some DHCP, some address resolution protocols, some DNS queries, some ARP, trying to find some other host out on the network. So there's a whole lot of ARPing going on. Okay, so that's what you get when you do a whole subnet at a time, all of these ARPs. Okay, and then basically it went right into the TCP three-way handshake piece, and that pretty much runs all the way down for the about 9,000 packets that I captured. And then I went back to idle. And I know that I'm at an idle at this point because I can see the broadcast traffic, the MBNS, or the multicast address type traffic. So I'm pretty much at idle at that point. So it's good to actually capture this because then we can write filters on it. I could do like an IP.src is equal to 192.168.92.2. and basically filter all that. Or I could maybe just look at all the reply traffic and do a DST, and I know that it's the right filter because if I get green here, green is go, red is no. All right, so now all the destinations are filtered correctly. Or I could just say, you know what, let me see everything back and forth between it, ADDR. And then boom, that's both source or destination, and I should be able to, see a 2 in some place. In this case, I just got lucky, and I can see the left versus the right. But the cool part is I get to actually see, both sides of the conversation by doing the ADDR. Sometimes you're interested in that, sometimes you're not. All right, so I just want to prove that, yes, we can capture it. And it's always good when you're learning the stuff to capture as you go and get used to reading the actual traffic as it goes on the network because it helps you become more intimate with the actual protocol analysis. And that's something that any firewall engineer or Trojan detection engineer or penetration tester is going to have significant interest in. You basically want to be able to spot anomalies just from these packet filters in itself. Okay. Now, the next scan that I actually want to do is I'm going to do a stealth scan, and it's very, very similar to what we just did, except instead of the nMap with a -st, okay, I'm going to go with S. And what this does is it also allows me to spoof my source address along with this. Now, I could certainly add this into the syntax of the command here, but in this case, I just want to see the requests come out and then back in and track a connection and actually see the flags go back and forth. So I'll go ahead and start that scan, and I'll hit enter a few times just to get an idea how fast it's going. Or I could go over to Etherape and then watch the actual traffic just for a little bit and just get an idea and a better feel for what's exactly happening on the network. And once your traffic is at idle, then you can go back to your command prompt and actually get your report. And it's very, very similar to what we had before. Okay, so I'm just going to scroll up and basically start at the top of the report. You can see very, very similar. Found some WSD APIs. I got the 92.2. I got the 92.128 address. Still, ports are closed. Nothing different there. I've got this server of interest, 92.131, specifically with NetBus installed. And it gives me the summary report from the end. So it scanned 256 IP addresses, only 5 are up, and it took about 20 seconds to figure that out. So let's see if we can't find a little bit more about that specific host that has NetBus installed. So let's do an nMap -O, and then the specific address, 192.168.92.131. Right? And I'm basically just doing an operating system guess at this point. And it happened so fast that I realistically couldn't show you what that looked like on Etherape, but it was probably just a quick swell and then back off. Right? So it found all of the ports just like it did in the previous scan. Found the MAC address, Windows 2000 XP. Okay, and in some cases we'll actually get a percentage of confidence in their answer. This case we don't. It pretty much knows dead on that it's a Windows 2000/XP build. But you can see little clues of that 2000. It pretty much pegged it exactly because it is Windows 2000 SP4 or the equivalent of Windows XP Service Pack 0 or 1, and it was one hop away. OS detection performed. And then basically, if there's an inaccuracy, if you want to report that back to nMap, that organization, you can do that. And it happened in only 2.5 seconds. So at this piece, we can actually just take a result of something and go in a little further and do an operating system guess. And it's really just realistically changing a little bit of the syntax and then doing it. Don't forget that I also could have just done the whole network and said guess everything on the network by adding the /24 there as well. The next scan that I want to perform is the Christmas scan, the fin scan, and the null scan. And I'm going to try to split my windows here just so we can see what Ether8 looks like in the background, at least as much as we possibly can. Okay, so I'm going to type nMap -S capital X, which is a Christmas scan, and I'm going to do it to the target 192.168.92.131. And we know that that is our Trojans Windows 2000 server. Okay, so I go ahead and do that. And you can see it basically just went out real quick, found it, and then went right back. So not really much in terms of a lot of traffic. That was pretty unidirectional. So it started the nMap scan, the nMap scan report for this particular host. The host is up, scanned all 1,000 ports on this, and the ports are closed. But it did find the MAC address. So how come when I did a TCP scan with a -S capital T or a lowercase s capital S for a half open or a stealth scan, I was able to get results, but this time setting the fin, urge, and push flags to that same server, I didn't get anything back? Well, the answer is easy. Windows is pretty resistant to trying for the client trying to communicate with the server if it does not have a pre-established TCP three-way handshake. And this is going to be pretty consistent for not only the Christmas scan, but the fin scan with a capital F. Okay, didn't find anything. In this case, it said the ports were closed. Or the null scan with a capital N. Okay, ports are closed. So Windows will not answer to a Christmas scan, a fin scan, or a null scan. Windows will not answer that. So the benefit of this actually is usable if you have some sort of Unix or firewall, depending on the version of the firewall client. Now, I just can look at myself real quick because I'm sitting on a Linux client and basically just kind of poke just to get a basic comparison. So I'll do an if config Ethernet 0, and then I'll basically scan myself. And I'll just go through the different types of scans. So first I'll do a Christmas scan to myself, and I'm at address 128, and basically see if I can see anything. And it basically, I don't have any ports open according to the Christmas scan. I'll replace that with a fin scan. Still thinks the ports are closed. I'll do that with a null scan. Still thinks the ports are closed. And then I'll kind of go back and compare that to the other types of scans, the TCP regular three-way handshake, to see basically if I'm supposed to be seeing that or is there an anomaly somewhere. And I got the same exact report back, and then I'll do a three-way handshake, and everything came back consistent. So in this case, the system that I'm on is hardened enough where it's not going to answer anything. So it's just too generic. And that would conclude a little comparison of the Christmas scan, the fin scan, and the null scan. So the next scan that we can do is a ping scan. Ping scan is a relatively easy scan to do. What we do is we basically start with our basic nMap, tag capital P, put in our network, 192.168.92.128, and then pick a subnet mask and go ahead and run this. Now, if you just put it with a regular P per se for ping, basically it'll come back and say that there's an illegal argument. Please use a variant of that. So if you want to know specifically what to do, you got to check the help file. So nmap tac h and look at the specific ping scan syntax. So you're going to scroll back up to the capital P, not to be confused with the lower P, which is for a specific port. This is basically the capital P for a ping scan. So you're going to scroll back to the top of the list, and you're going to go right in here where it says capital PS A U Y, which is the SYNAC UDP or SC TP discovery to given ports PE, PP, and PM which is ICMP echo times the netmask request discovery probes. So what you can do is try different variants of that, like PE, PP, and PM. Okay, so we're just going to go back up and basically do a PE specifically, and you can hit enter again to see the idea or the status of where it is in the scan. And also, if I can catch it, just get enough here, you can see basically what this looks like visually out on the network. And it's a relatively fast scan, so you can see that it just went out, pinged everything real quick, and I got the information specifically on the hosts that are consistently on this network: 192.1, 192.2, 192.128, and 192.131, which is our Trojan NetBus server. Okay, so go ahead and practice with that. Try just a regular ping scan to the network, which is basically just using lower TCP/IP layer 3 of the OSI model using ICMP, or you can move up to the upper layer 4 and basically do like UDP scans or TCP scans, which realistically aren't that different. Like, for example, if you wanted to do a UDP scan, you basically just do a -S uppercase U and go ahead and run that. And again, if you want to know where you are in the status, you can go ahead and get that. And then you can see what this looks like on our visual map here. And the reason why we like using this visual map is so that we can get an idea of how the traffic actually behaves, and you can get specific signatures and kind of get an idea of what port scans look like. A perfect example of here is if you were doing a regular scan that was literally one host after another, you would see it reach out and go to host 1, then 2, then 3, then 4, then 5, then 6. And so this diagram looks more like a fan. When you're doing a particular target or only to a specific groups of servers, you can just see that respective traffic. So it looks like now we're getting some volume back between the scan. And you just basically watch this like a movie until it goes down the idle, and then check your nMap again and see if it's there or not. And again, you can check the actual port status to see if it's open yet filtered, and for the respective, of course, ports that it is. So real helpful to do. Real nice to do, real easy visually. You can get an idea, one at the command line, and then also visually throughout the terminal. So that's quite a few different variants in the actual different scanning techniques. Everything from ping scans to, where I want your fluency to be is ping scans, Christmas scans, fin scans, null scans, TCP full connect scans, and then half open or stealth scans. Always start there, and then you can start moving on to the more advanced nMap scans, for example, the zombie scan or the idle scan or things like that. So don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter, and I'll go ahead and see you in the next video.